We tested that the database was created successfully, but now we should test that reading from and writing to the Sunshine database works as expected. I'll show you how we insert a row of data into the database, and then query the database to read it back out. First, we get a reference to the database from our SQLite Open Helper, which is an instance of an SQLite database object. We use this in test create_db. Since we're writing to the database as well as reading, we're going to get a writable database. If we were only reading, then we should use a readable database. To represent the row of data we want to insert into the database, we use a content values object. We create one of these in the create North Pole location values utility function. Content values contain a set of key value pairs. You put a key string associated with the value into the content value set. The key strings contain the names of columns in your database. The value can contain many different data types. Content values are used to write to databases in Android. Once we've created our content values, we call database.insert with the table name and content values to actually create the new row of data. The return value from our insertion is a long that contains the new row ID from the _ID column. If there's an error inserting, the return value is -1. Now that we have a row ID, we can query the database for that row. There are several query methods that take in different numbers of parameters. A query method is just a helper function to make it easier to construct and execute a select statement. Let's show how the query function constructs a statement. Here's what the base SQLite database query function looks like. The most basic query we can make with this only has a table name, and it returns all columns and all records. The rest of the parameters would modify and filter the output of this query. Adding a projection, an array of columns we wish to return, changes what we are selecting in the select statement below. The selection parameter filters the results. One can optionally also use the selection arguments to replace any question marks in the query. Android creates these as bound parameters in a low-level interface to SQLite, which means we don't have to worry about things like escaping the strings to keep the query valid. We can also change the selection arguments after our query has been made this way. The last parameter, as you would expect, affects the order by clause of our query, causing it to sort our result in descending order by date. The query functions all return a database cursor. A cursor object is a control structure that enables traversal over the rows and columns of our query result set. Typically, we'll start traversing result set by calling cursor.moveToFirst, which will return false if there are no rows in the result, which means nothing matched the query parameters. We can then call moveToNext to iterate through each row. Once the cursor points to a valid row, one can call getColumnIndex to return the index of each database column within the result set. You can save these values and use them for every row in the result. And then you can call getter methods that retrieve the values from that row based upon column index. Everything we've covered so far is how we read and write from the database in our app, in tests and in our app code. For our unit tests, though, we add a step to validate the values from the cursor with the ones we originally created the content values object with by using assert statements. And when we're finished, we should close our cursor and database to release the system resources as soon as possible.